Hello and welcome back. In this video we'll be continuing looking at section 2.3 on linear functions and their slopes. So one thing that's going to help us write down the equation of a line is to use the Y-intercept. The Y-intercept is just where our line is going to hit the Y-axis. And when it hits the Y-axis, the point is always going to be the form 0b. 0 is the x value because we're not to the left or to the right. We're right on the y-axis. And b is just going to be how far up or down the y-axis we are. So the y-intercept is just b. All we need to know is b to know where the line will hit the y-axis. So this y-intercept, this point 0b, is quite nice. X is 0 and then y will be b at that point. So if we use our point slope form, so again here this is the equation of a line with slope m that passes through the point x1, y1. Well, if our line hits the y-axis, we can use that in here. So for instance, if I substitute 0 in for x1 and b in for y1, we get the following. Well, I can simplify this. X minus 0, well, that's just x, so the right-hand side simplifies to mx. And if I add b to both sides, I can cancel that over here, and I get y is equal to mx plus b. So now I have this equation where I have the slope and the intercept, and I know that the picture will look like this. This is called the slope-intercept form. The general equation is just a nice equation for a line with slope m, and it intersects the y-axis at point B, and we have our formula. So when you're solving an equation, you can always just try to solve for y, and as long as the right-hand side is going to be something times x plus something, we know that we have a line. We can figure out what the slope is and where it hits the y-axis, which makes it very easy to graph. So let's graph this function. So our function is going to be 3/5 x plus 1. So remember that when we graph a function, we're going to treat this f of x as the height y along here. So we do have our function in slope-intercept form. So our slope is going to be m, which is 3/5, and our y-intercept is going to be 1. So what does it mean to have a y-intercept of 1? Well, our line is going to pass through the point 0, 1. It's going to hit the y-axis at this point. Also, having a slope of 3/5, the slope is going to be the rise over the run. So for every 3 that we go up, 3 is the rise, 5 is the run. So this is how far we're going to go over. So with a slope of 3/5, when we go up 3 points, 1, 2, 3, we need to go over 5. 1, 2, 3, 4, 5. So the next point in our line will be somewhere over there. So we can draw a straight line that goes along there. So this is fairly easy to draw. The first step is identify your intercept. So this is going to be our y-intercept. Maybe I can do that in red. And then the next point is just to find another point along the line using our slope. So you count the rise over the run. This is already a nice fraction, so we go up 3 and over 5 to our next point, and our line is just going to pass straight through those 2 points. It's pretty straightforward. Let's do another example. So here we have y is equal to 3, and immediately when we look at this, we go, well, this isn't y equals mx plus b. There's no x. Well, it's just hiding. So one way to write this down would be to write this down as y is equal to 0 times x plus 3. If I write 0 times x, well, 0 times anything is 0, so I could cancel this out. So this equation here is in fact in slope-intercept form. It's just hiding. Now let me graph this without really considering the slope-intercept form for a second. Y is equal to 3. So the question is, for what x value? well, if it's not specified, x can be anything. So when x is 0, y is 3. When x is 2, y is 3. When x is negative 3, y is 3. No matter what x is, no matter what x is, y is always 3. So we just have the straight line. Now, does this make sense? If we think about this in slope-intercept form, our slope is 0. Well, hey, it's a flat line. It's perfectly level. This means that we have slope 0. Okay, that works. And this says that the intercept should be 3. Well, our intercept, where our line hits the y-axis, is 3. So everything works out exactly how we would expect. We can either graph it just y is equal to 3, and we have a straight line, or we can put this in slope-intercept form and go, the slope is 0, the y-intercept is 3. Either way works. And this, in general, is the equation for a horizontal line. And again, when I write down y is equal to b, we can expand this a little bit and say y is equal to 0 times x plus b. So this is sort of off to the side. We can think about it like this. So the slope of a horizontal line is always 0, and then the y-intercept we can read off as b. So when we're given an equation of line, y is equal to b, we know it's horizontal, it has slope 0, and we can find the y-intercept. So it's pretty easy to graph. Let's look at this one. So now we've got x is equal to negative 3, and this is a little bit harder to turn into the equation of line with given slope-intercept form. So I'm just going to graph this like this for the moment. So the line x is equal to negative 3. So the question is, what is y? Well, if it's not specified, it can be anything. So when y is 2, x is going to be negative 3. When y is negative 1, x is going to be negative 3. When y is 0, when the height is 0, x is going to be negative 3. And we can see that no matter what y is, no matter what height we're at, the x value is always negative 3. This gives a vertical line. And in fact, we can't even write this in slope-intercept form because the slope of a vertical line is undefined. M, in this case, our slope, is undefined. There is no number that I could plug in to make this work. So I can't write this in slope-intercept form. So, and this is always the equation of a vertical line. Vertical line is always given by x is equal to some number, and then we'll just have a vertical line at that point. The slope is always going to be undefined, and there won't be a y-intercept because this is going straight up and down. It's never going to hit the y-axis. However, it does have an x-intercept. It does intersect the x-axis, specifically at A. So that's about all we can say there. So we have equations for vertical lines, horizontal lines. We have slope, point slope form and slope-intercept form. It turns out we can always write every equation of a line like this. So out of all of the equations, we can always write it as this: something times x plus something times y plus some number. So just a constant, and we can just set all that equal to 0. So every line can be written like this. So what we'll do is we'll start with a line that looks like this in an example, and we'll graph it and we'll learn about it. So here we have an equation 3x plus 6y minus 12 is equal to 0. And they're asking for the slope and the y-intercept. There is a form called the slope-intercept form. Let's put it into that form, and we'll be able to read off the slope and the intercept. So remember that slope-intercept form is y is equal to mx plus b. So the key feature here is y is by itself on this side. So let's solve this equation for y. First, I'm going to add 12 to both sides to get 3x plus 6y is equal to 12. Y isn't by itself yet, so I'm going to subtract 3x from both sides. To get 6y is going to be equal to negative 3x plus 12, and I'll divide both sides by 6. To get the final equation, y is equal to negative, so 3 divided by 6 is 1/2, times x, plus, and then 12 divided by 6 is 2. So here we've got our nice equation. Y is equal to negative 1/2 x plus 2. And the great thing about this equation is that the slope is what's multiplying the x. So our slope is negative 1/2. Our y-intercept is the 2, just from this equation. So that's it. But also, once we have this equation, we can graph it once it's in this form, because it's pretty easy. So if I go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, our y-intercept is 2, which means that this line is going to hit this the y-axis at 2. So we come up 2, and this is our point. Our slope is negative 1, 2. So remember that slope is going to be rise over run. So we're going to rise negative 1 and run 2. Well, if we're going to rise negative 1, that just means that we're going to go down 1. And with a run of 2, that means we're going to go to the right 2. So down 1 over 2. And we can continue doing this, down 1 over 2. And all of these points are going to be on a single line. It's going like this. Again, the important features, the y-intercept, that tells us where to put the line, and the slope tells us how inclined this is going to be. It's a negative slope, so it's decreasing, and we're going to go down 1 for every 2 we go over. Down 1 over 2, down 1 over 2.